The bridge to the Ruski Island over the eastern Bosphorus Strait is being built under a federal program of Vladivostok development as a center of international cooperation in the Asia-Pacific region. The new bridge will be a link between Vladivostok mainland and island areas to become an important part of Primordia region transportation system. This bridge is of unique dimensions. The bridge is 70 meters high above the water level, and the central span is more than 1,100 meters long. The bridge will break the world records. Pylons will be 320 meters high, and the stay cables will be 580 meters long. Bridge construction started in September 2008 and will be completed right before the Asia-Pacific Economic Cooperation Summit to be held in Vladivostok in 2012. The builders have to work under extremely challenging weather conditions. The wind speed is up to 36 meters per second. The storm wind raises waves that are up to 6 meters high. And the ice is up to 70 centimeters thick. The temperature in winter drops below 30 degrees minus. And in summer, it is up to 37 degrees hot. Two production facilities were put in place for running efficient construction operations. One facility is located on the Nazimov Peninsula and the other on the Ruski Island. The facilities include a rebar welding workshop, building laboratories, and state-of-the-art concrete mixing plants supplied by Techwil Oy and Compactors companies. Each production facility has mechanical woodworking and equipment repair workshops, office buildings, living quarters, and canteens. More than 1,300 meters of new railway tracks were built to ensure timely delivery of building material. The existing railway section of over 4.5 kilometers long was upgraded. About 320 pieces of state-of-the-art special equipment are used in construction of the bridge to the Ruski Island. Unique 40-ton and 20-ton Kroll tower cranes, which can telescope up to 340 meters, are used for erecting the pylons. Russian-made derrick cranes of up to 400-ton lifting capacity are used for installation of the channel span deck. Leibherr crawler crane of 1,350-ton lifting capacity has been installed within a record short time for lifting the first 10 sections of the steel span deck on the Ruski Island. Viaducts of the total length of over 900 meters provide approach to the bridge. The viaduct piers are made as columns that are from 9 to 30 meters high. The span decks are made of steel and reinforced concrete, consisting of steel inclined wall box sections and a cast-in-place reinforced concrete slab. The bridge piers M1 on the Nazimov Peninsula and M12 on the Ruski Island are the heaviest and most complex structures. They are about 35 meters high. The number 1 and the number 12 are used as the load transfer piers. They take up the horizontal load from the cable-stayed span stiffening girder. The builders used self-compacting B35 grade sulfate-assisted Portland cement concrete for erecting bridge pier and pylon grillage. The concrete will protect the footing against corrosive fluids and prevent rebars from getting rusty. A man-made eyelet was rock-filled for pylon M6 footing borehole drilling on the Nazimov Peninsula. The pile footing for M7 pylon on the Ruski Island was built from the water, using a temporary steel eyelet. A man-made peninsula was rock-filled after the drilled piles and enclosing sheeting had been completed. This small peninsula is designed for the production against impacts of vessels of up to 66,000 displacement tonnage ice drift and waves. A total of 1.5 million cubic meters of rock and dirt were moved for building the construction sites on the Ruski Island and Nazimov Peninsula. Drilling and pile concreting operations were conducted from the water at sea for the first time in bridge building in Russia. The water depths in various areas of operation varied from 14 to 20 meters. 120 drilled piles, each 2 meters in diameter, have been put in place to build the footing of each pylon. Permanent steel-cased piles under M7 pylon have been sunk 46 meters deep. The reinforced concrete piles on the Nazimov Peninsula go 77 meters deep. It took about 20,000 cubic meters of concrete mix and about 3,000 tons of steel structures to erect the grillage for each pylon. This was the most labor-consuming and critical operation of the bridge construction project. Strain gauges are embedded in the grillage body for monitoring health condition of the giant footing. Custom-made self-lift shutters are used to concrete the pylons. 7 working tiers of a total height of 19 meters allow the preparation of the construction joint, reinforcing, concreting, concrete cure, and finish to be run simultaneously in 3 sections that are each 4.5 meters high. The shutters move on their own by hydraulically powered lift modules. The self-lift shutters cut down the cast-in-place reinforced concrete structure erection time by a factor of 1.5. This is a significant time gain, given that the total scope of concreting for each pylon is over 20,000 cubic meters. The stiffening girder of the central navigation span of the bridge to the Ruski Island is all metal. It is made as a box that makes up the entire cross-section, with the bottom orthotropic and top orthotropic plates and a system of transverse diaphragms. The steel stiffening girder consists of 103 panels, each 12 meters long and 26 meters wide. The panels weigh a total of 23,000 tons. The stiffening girder is 1,220 meters long. The panels are delivered to the installation site by barges and are then lifted by crane to the 76-meter elevation. The barge is positioned under the installation unit using GLONASS, a Russian global navigation satellite system. After the section number 20 has been installed, paired panels that are 24 meters long are delivered for installation to expedite installation of the steel stiffening girder. The panels are pre-assembled at the production facility on the Nazimov Peninsula and at Nakhodka shipyard. This procedure rules out additional operations of fitting the heavy tonnage panels during installation, which is important because the work being conducted under strong winds at the elevation of 70 meters above the strait. The time gain will be significant, given the fact that over 30 kilometers of first-class welded joints with 100% ultrasound flaw detection have to be completed. An improved stay cable system with a higher strand density within the jacket is used for the bridge over the eastern Bosphorus Strait. The stay cable system weighs 3,720 tons with a total length of over 54 kilometers. The stay cables are composed of 13 to 85 parallel, individually corrosion-protected strands. Each strand consists of 7 galvanized steel wires enclosed in high-density polyethylene sheathing. A compact cable configuration using a smaller diameter jacket reduces the wind load by 25 to 30%. This design cuts down the cost of materials for the pylon, stiffening girder and footings by 35 to 40%. The stay cable jacket is made of 2 plies. The inner layer is of black high-density polyethylene, and the other, thinner layer features the Russian national flag colors. The ornamental jacket also has a helical groove for the protection against vibrations under combined exposure to rain and wind. The comprehensive mechanical protection and quality monitoring throughout fabrication of all stay cable components ensure high strength, durability, and corrosion resistance indicators. The stay cable design service life is of at least 100 years. The bridge construction has attracted numerous visitors and specialists from the very beginning. Government commissions, foreign delegations, and journalists could be seen on the project site practically every month. When construction has been completed, the Vista platform will be open to the public, and the bridge to the Ruski Island will become one of the most important landmarks in Vladivostok, a logo for the city, for the country, and for the SK Most Group of companies.